Online, anyone? Am I?
Yes.
Is my mic on? Good question. It is on. But no one wants to speak up. Very important to speak up, yeah? I wouldn't know.
No, that's it.
Can see ka tadi? Okay. Is it visible?
Right.
We need to
Check.
pixelated. See if we can do this. Dekat sikit. Dekat. Okay lah. All right, let me see. Not this one. This 20 only. Already time, right?
Oh yeah, it's 5 minutes.
Shall we begin? Online? Can anyone say something? Oh, it's echoing already because you went before it. Hello? No one wants to say anything.
No one wants to check something. On your voice, say.
Yeah, okay lah. Okay lah. We proceed. Let's look back at where we left off. We were in learning unit 2, the second part. Okay, we were talking about complex roots for the characteristic equation. Okay, so remember, I hope you have already understood how to obtain the general solution when your characteristic equation, the roots of the characteristic equation are complex. Yeah, so all that is in these slides. So basically, you will need the Euler's formula, and then you will also need to manipulate the linear combination such that you have y1 plus y2 and y1 minus y2, so that you will get rid of the imaginary value, yeah, imaginary term, sorry, yeah. So you have y3 and y4, and that will be, and you will need to show that the Wronskian of the y3 and y4 are non-zero, hence it forms a fundamental solution. Then in the end, slide 5, yeah, so slide 5 shows the general solution when you obtain complex root for your characteristic equation, yeah? And we did some examples. Okay, now we will continue to the next one. So obviously, this will deal with the when your roots of your characteristic equations are real and the same. Okay, real and the same. So I am on slide 11 right now. Okay. So repeated roots, what does it mean is because our roots of the characteristic equation are R1, which is equal to R2. Yeah, so this is what it means by repeated roots. Yeah, the roots are the same. Okay, and hence we will be using the method of reduction of order. Okay, so in order for us to find the general solution, remember our general solution would be T1 e to the power of R1 T plus C2 e to the power of R2, right? So now if it is the same, R1 is equals to R2, then we will not have C2. We will only have one constant, yeah, constant of integration, which is not right, because this is a second order differential equation. Therefore, we expect to have two constant of integration. All right. So hence, we will need to deal with it using reduction of order. Okay. So on this slide, slide 11, yeah, I'm still on slide 11. It tells you what it means by repeated roots. So basically, when you use the formula to find quadratic roots, because characteristic equation will give you a quadratic equation. When you use that, the terms inside the square root, the b square minus 4ac is equal to 0. That will give you R1 is equals to R2, yeah? So from there, if we were to simply follow, because R1 is equals to R2, we were having this minus b plus or minus b minus 4ac over 2a. So this is 0 for this case, hence we will only have R is equals to minus b over 2a. That gives us the general solution to be t minus b over 2a t. Okay, so this is one solution. Okay. So we know that we can actually find a second solution. So this is one solution. So the second solution is simply multiplying the first solution with a multiplier. Okay. So for this case, yeah, so we have a CY1 is also a solution. Okay. So Y1 and Y2 are linearly dependent, and we generalize this approach and multiply instead of a constant. Yeah. So we say that it is a function. Okay. So we multiply a function instead of a constant because we want to generalize it. Okay. So hence this is set of constant. We call it what do we call that? Function b. Okay, function b, which is a function of the independent variable t. Okay. So the question would be, what is b? Okay, that is our main aim now, is to find what will b be. Okay. And we will need to see or determine the conditions for which Y2 will become a solution as well. Okay. So that means that since Y1 is a solution, therefore Y2 should be a solution as well. So that is what we are trying to do. Okay. So now, so that means our hypothesis is that Y2 equal to B e to the power of minus b over 2a t is
Those online meeting can say they cannot see the so maybe I can adjust the camera a bit. Maybe I just higher object. Because the camera.
Yeah. Right? Dan rasakan dia sudah.
Ya, nak betul ada.
If we were to let go of this, it will be worse kah?
Worse.
Worse. So you want to make it higher. Okay. I found a box.
Very small.
Very small. I thought we just need a little up.
Is that okay?
The box.
Okay. Is that okay? Okay.
Sini. Nampakkah? Nampakkah?
Some of them PM me, but not so.
Online, we are concerning about you. Can you say something?
They say a little more,
What?
a little more.
A little bit more higher. A little bit more higher. Ada box lagi kah? Buku. Oh, you guys don't carry books.
Can I use my iPad to most expensive? Most favorite.
Okay, try that.
Okay.
Bagaimana?
You think you're still sharing your QR to this page?
Oh, tidak. Itu berdetail, bang.
Oh.
Oh, wonder. Stop sharing ya. Sudah ambil attendance, tengok berapa orang, 24 saja. Ya.
Oh, there's that.
Hebat.
Oh, okay. It's still.
Oh, that's
I don't think the box counts.
Ya, huh? Macam ini.
So now okay already.
Okay. But
Of course, I'm doing like this.
at an angle.
No. I think we
I think
put
we need to like get back.
Put at the back.
Yeah.
And then put this whole thing. Yeah. And then Rebecca will do like that. Sorry.
Is that?
Oh.
No, it's too short. Yeah, the wire.
Aku.
I think we need to move the table a bit. Yeah.
Kevin, try your face.
Wait, I think I solved it already.
Huh?
Oh.
You can just scroll the.
Yay!
Adjust the camera.
Scroll saja. Okay. Yeah, no need my feet.
Okay.
Okay, now.
Oh.
Okay.
It's too
Thank
technical.
you.
High class.
Kelvin, Yusala, Kelvin. Kevin or Kelvin? Kevin.
Let's go. No one can see.
Okay.
Okay. So I am now in slide 12, yeah? Slide 12. So what happens? We are saying, aduh, sudah padam tadi. Yeah. So we are saying that y2 is equals to b t e to the power minus b over 2at is a solution to the ODE. Okay, so that means that when we substitute this into our ODE, okay, then it also satisfies. So what is our ODE? The usual one, yeah? So our ODE is the usual one, ay double prime plus by prime plus cy equals to 0. So which means that we need to substitute this into our ODE. So we need our y2 prime. So y2 prime is b minus b over 2a e to the power minus b over 2at plus b prime e to the power of minus b over 2at, okay, plus, okay, cukup luas saja.
Itu sih.
That's it, right? Then y2 double prime. Okay, this one will be 4.
Very, very long.
4 terms. So we have b b over 2a square e minus b over 2at plus b prime minus b a e minus b over 2at plus b prime minus b over 2a e minus b over 2at plus b double prime e minus b over 2at.
Yes.
Okay? Sub into ODE. Okay, sub into ODE, so which means this, substitute into
There.
our ODE, this one. So that will be quite long, which is shown in the next slide. Yeah, quite messy, but you need to understand what's going on there. Yeah. So next slide, I am now on slide 13. So what happens is that these three they are substitute into the ODE. Yeah. So A, and then all this. Kalau saya letak. Minus lagi B prime. Oh, this is 2. This and this are the same, right? Am I looking at the same? Yeah, they're same, right? So I can make this to be 2. Minus 2, yeah? And then plus B double prime E minus B over 2AT. That is coefficient of A plus B. So B will be multiplied with Y prime, and that gives us minus B over 2A e to the power of minus B over 2AT plus B prime E minus B over 2AT. And then plus C B E minus B over 2A. All that is equals to 0. Okay? Daripada ini, so now we need to tidy this up. Okay. Tidy that up. Every term has the exponential term, so we can factor that out. So E minus E T over 2A, all that we have first the A. What happens in here? Nothing can be done, right? I just want to rearrange the V prime, V double prime to be this side and V that side. So I'm rearranging that. The higher order term first, yeah? So V double prime, so E to the power, that one sudah keluar. Then we have minus 2 V prime plus B. Okay? Lupa B over 2A. Minus. I can cut this, yeah? I can cut that. Should I cut it? minus. Just got it. So we have
B
B over
A
A
B
B prime plus
B.
2A squared.
A square B.
Betul? Eh,
Itu
tak betul.
A
Unless I use this one I use bracket. Then okay. Right? Then I have my B plus B. E still nothing, but we rearrange, so we have B prime minus
B
B over 2AB. That's it. And plus C B. All that curly bracket equals 0. Sama kan? Okay. Then we have to open it. Open the one inside the curly bracket. Okay. Open the one inside the curly bracket. So we have AB double prime minus BB prime
B square.
plus, right? Plus
B square over 4.
E square over 4A. Yeah, because A will cancel one of the A there. Then B,
plus
then plus BB prime minus B square over 2AB plus CB. Not too bad. Not too bad. This cancels, right?
yeah.
Yes, sir.
Right?
Yeah.
This cancels.
And then the
This and this becomes
uh,
minus half. Minus quarter, right?
B
So
square
we have E minus B. Jangan lupa ini.
2 over 4 minus 4 over 4.
Okay, so we have A, B double prime. Then this and this becomes
B square
minus, right?
yeah, minus.
Minus, right? So minus B squared B over 4A
Okay.
plus CB.
This.
CB juga kah? Oh, it's all B.
B.
So B prime gone because we cancel. Okay. So we combine this. Okay, never mind since sudah tulis. Kali lagi. A, B double prime. So this and this becomes plus B
How do you equal to negative B square minus 4A?
1 over 4 minus 1 over 2.
Equals to 1 over 4 minus 2 over 4.
1 over 4 minus 1 over 2. Jadi apa?
Negative 1 over 4.
Correct? Itulah jadinya.
Jadi 2.
Terima kasih Kevin. Okay, ini jadi apa? Cannot do anything because
B minus B square.
because they are all different. Tahu tak? Okay lah. So it's 4AC over 4A. Okay, and then they put the B square in front. If you were to put the B square in front,
B square minus
so it becomes B square minus 4AC. This one is minus lah, right?
Yes.
Right? Need to this become minus, and then this.
Our friend balik.
Okay. Now, why we want that is because saya sudah padam sini. Do you remember that b square minus 4ac, the one inside the square root is equals to 0. So therefore, this is equals to 0. And that leaves us because this is not equals to 0. So therefore, this has to be equals to 0. So this means that B double prime is equals to 0. Okay. Now, what does it mean? B double prime equals to 0. It means that is equals to a constant. Right? Because when you differentiate this, then it becomes B double prime, and differentiate constant is equals to 0. So you get like this. Yeah. Now, B prime equals to K, a constant. So that means it's dV dt, right? Is equals to constant. So we have dV equals to K dt. So you can integrate that. And then you have B is equals to KT plus another constant. So on the slide, they chose the constant to be K3 T plus K4. Same thing. Boleh? Belum siap lagi. So far, what did we do? We only found V. So this is our V that we wanted to be placed here. So now we have Y1 and Y2. Okay, remember our Y1 is only this. And then our Y2 now becomes K3T plus K4 e to the power of minus b over 2kt. Right? Now, if you remember, now I'm going to padam this. I hope you guys already take note of this. And I hope you are following me. So what happens here? Remember our general solution is y is equals to y1 C1 y1 plus C2 y2. So our C1, our y1 is e to the power of minus b over 2kt plus C2. Now our y2 is K3 T plus K4 e to the power of minus b over 2kt. Yeah. So if you were to buka dia, this is so that everyone is clear. This is just a constant. Let me call it C3. E to the power minus b over 2kt. This is another constant C2. Another one C4. C2 times K4 becomes C4. So it's E minus B over 2kt. But you can see that the first and the second and the third term actually same. You can put it together to be another constant plus C3 TE over 2kt. Okay, so finally, this is our general solution. Boleh? Yeah. So when you have a repeated roots, okay, when you have repeated roots for your characteristic equation, you know the general solution will be, so I rewrite this now, I rewrite it to be y is equals to p1 y1 plus p2 p y2 because of this. There's a difference. Bukan y2, y1 lah. The same lah. Okay. So that is what type of thing is. Okay. Then of course, so now we are saying that that's the general solution, and hence, will it be a fundamental set of solutions? So you need to find the Wronskian. So slide 15 is showing the Wronskian. Y1 and Y2, then you will need to get its corresponding derivatives of each of Y1 and Y2 so that you can substitute inside the Wronskian formula. Yeah, so Wronskian, remember Wronskian of Y1, Y2 is equals to Y1, Y2 prime minus Y1 prime, Y2. Okay. This minus this. Yeah, so. Okay. So this is the formula. Essentially the determinant. So, and it shows in slide 15 that it is non-zero, hence Y1 and Y2 are fundamental set of solutions. Okay? All right, so now slide 16 is to simply use the general solution that we obtain, yeah, for this type of roots. Okay, so for this case, so our y double prime plus, so this is example 1, y double prime plus 2y prime plus y equals to 0, and it is an IVP, yeah, it's an IVP. So you are given the initial condition at y, which is 1, and y prime is equals to 1 as well. Okay, so you know how to start for solving the this. So you say what? Assume the solution is in the form e to the power of RT, then y equals to e RT, y prime is equals to RE RT, y double prime is equals to R square E RT. Yeah, remember this is counted, so don't jump. Okay, sub into the ODE to have R square E RT plus 2 R E RT plus E RT equals to 0. ERT R squared plus 2R plus 1 equals 0. Since ERT is not equals to 0, then R squared plus 2R plus 1 is equals to 0. Then is the characteristic equation. Okay? Very, very important to write all this. Yeah, don't jump straight to this and then find the truth. Yeah.
How much mark will be given?
Huh?
How much mark will be given?
Usually 3. Usually.
Oh. Oh. Yeah, already 3 marks for the whole question is. What?
Okay. Then this one is easy to factor. So this is R plus 1 square equals 0. So therefore R is equals to negative 1. Yeah. The general solution to the ODE is y equal to C1 e to the power of minus t plus e to t e. Boleh? Okay, now we apply. We want to find C1 and C2. We need to apply the initial condition. Y is 0 equals to 1. Y is 0 is equals to C1 plus equal 1. So therefore C1 is equals to 1. Apply Y prime 0 is equals to 1. We have Y prime equal minus C1 e to the power minus t plus, okay, you want to start with minus, okay, minus t to t e minus t plus t to e minus t, right? Okay, so y prime of 0 is equals to minus C1 minus 0 plus C2 equal 1. Yeah? So substitute C1 is equals to 1, then C2 is equals to 2. All right? Hence the specific solution to the IBP. You need to say it's IBP now because you have already applied the initial condition. Then the specific solution to that is y is equals to e to the power of minus t plus 2t e minus. Okay? Or in other words, to make it nicer, this is 1 plus. All right, and then you can also graph that out as shown on slide 16. Okay, any question? So far so good? Okay, I want to move a bit faster. So example 2, nothing new there. Also the same way of solving, yeah? Same way of writing down your solution. So for this case, you'll get the repeated roots to be half, substitute in, and then apply the initial condition and obtain the specific solution, yeah? Okay, so that is example 2. Example 3, also the same thing. It's actually the same in ODE, yeah? Example 2 and 3, they are actually the same ODE, but the initial conditions are not the same. Okay, example 2 and example 3. Same ODE, different initial conditions. So hence, specific solution will be different. But general solution is the same. Okay, you notice that, right? Okay. All right. Now, the beauty about this is that what you have learned just now, in order for you to obtain the general solution for repeated roots, is where you have already learned the method of reduction of order. So let's look back on this particular method, which is very important, yeah? So because in the method of reduction of order, you start with one solution and you hypothesize, you say, hey, I can find a second solution, whereby you multiply that first solution with a function of the independent variable. And then try to find out what is that multiplier. Okay, so that is method of reduction of order, yeah? So you need to know that as well. Okay, you need to know this method. All right, so on slide 19 is generalizing the method, yeah? Generalizing the method. You look at slide 19. We put it into a general form of the ODE, which is y double prime plus some function t multiplied by y prime plus qt, a function of t multiplied by y. Okay, so this is a general way of writing ODE, yeah? Whereby the coefficient of y double prime is 1. Okay, so what did we say? Suppose, yeah, so suppose y1 is a solution to the ODE, then we hypothesize, or we try times y2 equal to v of t y1 is a solution. Okay, so what did we do just now? Because it is a solution, therefore it has to satisfy the ODE. Okay, so substituting y2 prime is v y1 prime plus v prime y1, yeah, and y2 double prime is equals to v y1 double prime plus v prime y1 prime plus Now this b prime y1 prime plus b double prime y1. So that is equal to b y1 double prime plus 2 b prime y1 prime plus b double prime y1. Boleh? So substituting this into the ODE. So y double prime, which is this. So we have b y1 double prime plus 2b prime y1 prime plus b double prime y1 plus b y1 prime plus b prime y1 plus q y y1. Yes, correct. B y1 equals 0. Okay, dokie. Now we need to collect all the terms of the V's. Okay. Want to collect all the V terms, so we have V double prime y1, yeah, y1 plus then v prime, okay, v prime we have 2y1 prime, 2y1 prime p y1, right? Plus py1. That's it. And then plus b, or b, y1 double prime
Plus py prime.
is that right?
Py1 prime.
Plus py1 prime,
Plus Q
is that right?
Y1.
Plus qy1. So, have we gotten everything? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright. So all that equals to 0. Alright. Okay. So now, look at this. The last term on the square bracket, it is exactly the same as our ODE. And since y1 is a solution, hence it applies. Okay, y1 is applied to this, so therefore this becomes 0. The whole square bracket, yeah. So we are left with b double prime. So since y1 is a solution, then it satisfies the ODE. And we are left with b double prime y1 plus b prime 2y1 prime plus py1 equals 0. Sama? Sama, right? Okay. So what it is saying is here, right? So which means from here we should be able to find our V, because our aim here is to find the V. Okay. So this is an ODE. Okay. So this is a function, y1 is a function of time, the independent variable, and this is also a function of the independent variable. Therefore, this is, because you have v double prime plus v prime equals 0, so you can actually see that this is a first order differential equation.
Yeah.
Okay? So hence you can find v from there. Alright, so let's try to do that using an example, through an example. Let's look at example 4, slide number 20. Okay? So we have this differential equation t squared okay, a bit different, but never mind. So t squared plus 3t plus 1y. Okay, and you are given the first solution, yeah, the solution t minus 1. Okay, so hence alamat sudah padat. Using the method of reduction of order, we y2 is equals to v of t minus 1. Okay, it's a solution substituting y2 prime. So y2 prime is v minus 1 over t would be minus, okay, then v prime is v y1 double prime, t minus 3, right? Huh? Oh, 2. Then v prime, y1 prime is minus, kan tadi? Minus then v prime the same. Oh, we should have just put simply apalah. Minus, right?
Yes.
Plus v prime double prime yeah. This is 2v t minus 3 minus 2v prime t minus 2 plus v double prime okay. substitute into the ODE. Substituting to have panjangnya. Ada T square lagi ni. Tengok ni, ada T square lagi. Padamlah dulu, pening je tengok. Alright, T square 2V T minus 3 minus 2V prime T minus 2 plus V double prime T minus 1 plus 3T FVT then negative VT minus 2 plus V prime T minus 1 plus V T minus 1. All that equals 0. Okay, then we need to rearrange and hope something will be 0. Yeah, so when you reach this stage, you know you need to, there must be something will be 0 already. Okay. So that T square, huh? T square. So T square dengan 2 becomes what?
2V
2V T minus 1, right?
Yes.
This one cancel out minus 2V prime plus V double prime.
T.
Apa jadi?
T.
E minus right?
Minus
Oh. 3
T minus 1
P minus
plus
1
B1.
B1
B1 again.
B1 V prime
B
3
prime.
right?
3 V prime
3V prime
Plus B.
okay,
Collect the B.
collect it. So we have V double prime and then V prime is this and this, right? That is
Plus B prime.
plus V prime.
That's all.
That's all. Okay, let's see total. So we have this and this become minus 2. So that minus 2
Plus 2.
plus 2 cancel. Yay! So that is equals to 0. Okay? Wonderful. Okay, so then, now we need to solve for V, right? So let U is equals to V prime. Then that equation becomes U prime T plus U equals 0. So it's a first order, yeah? First order which you can solve. So this is, you can separate it. So du dt E equals to minus U. So you have du over U is equals to minus dt over. So that's ln U equals to minus ln
T plus
T plus
C.
C. Okay, so therefore U is equals to
Exponent T over T.
So you have U is AT lah.
Okay.
Alright.
yeah
3. T.
So,
Oh, the T then negative. Negative.
Huh?
Negative long T. Negative long T.
Oh,
T power
negative.
negative.
So it's minus.
No, it's T power negative 1.
Power.
Yeah, yeah.
Okay, so we are not done yet because of this. Okay, so that
E prime.
we have B prime is equals to
A over T.
A over T. So dB is equals to A
T over T. Long
S of
T
B
plus C.
is equals to
Long T.
T plus C. So in other words, yeah, same thing as what they are saying here, right? Okay, so then the second solution is y2 equal to
A long T plus C over T.
1 over T A ln T plus C. So then
We call that
general solution
Y1
daripada semuanya
T.
general y is equals to C1 over T, right? Y1 plus C. Okay lah, I write supaya you ingat. C1 over T plus C2 over T juga. Then you have A ln T plus C. Now we can combine this and this together.
Yes.
Yeah. So therefore y is equals to K1 over T plus K2 over T ln T. That's the general solution. Okay, so obviously if you leave your solution there, it's still not quite correct. Huh? Yeah lah? That this is the correct. Okay, so that is how we use method of reduction of order. All right. You want to take a break?
Yes, please.
Okay. This is a huge. We have another 2 more.
Is this chapter like the most heaviest? Oh, I've got
No.
other heaviest
The
again.
last chapter,
Well, this is not even the worst.
All of them is quite heavy. The next chapter is series. Lagi teruk. Lagi banyak you have to write.
How many series?
No. Series solution is also a method, but you are using series. Here, you are assuming with characteristic equation, yeah, you are assuming the solution to be e to the power something, right? This. Tapi in series solution, you are assuming it to be a series.
Or like they were just like assuming.
We assume it as a series. The solution is of series form. Anyway, itu belum. We still have many. Okay, pee break. Pee break. I give you 5 minutes lah. Can I have QR? Okay, you can.
Baru orang.
Okay. are the same to R. Okay. All right. Please take your attendance. Those who come in late. Aduh.
Next Friday. No. It's only 8.
Oh.
Oh, wow. Oh, which was the time? Was I correct?
No. Not.
Oh. I'm going to check it. Oh.
Yes, but that was done inside. But that was
Inside. She's started.
it was done.
Do you guys like running?
Running?
No, not really. Why?
Not
Yeah,
marathon.
I'm looking for people to run
Which faculty?
5 km. Any union, anyone. So can you let me, if I can forward,
3 km idea on the back.
to help me to
Okay.
forward to your friends?
Wow.
We are looking for union.
Artificially run quick. Okay.
Is it for faculty or?
No,
Yeah.
Unimas.
What
We
event?
represent Unimas.
Oh.
For what event? Shiva.
It's a Rotary
Oh,
Kuching charity run. Okay, I don't have any of your number. Is that?
Do we need to pay for the?
Is this you, Rebecca?
010.
01061.
010.
Is this?
Oh wait, 010. Oh yeah, that's me. I forgot. I remember. 010653545. Okay. I don't know how I remember my step.
Oh, yeah, that's right. I don't think it's a faculty. Which one? Yeah. Oh, that's so.
after second.
Just forward lah for me. Anyone you think that would want to run.
Everyone at Raya, everyone balik Raya.
Hey, what?
So
When is
it's
that?
7th of May.
Oh, May.
7 of May after, second week.
Yeah.
Oh, during cuti Sem.
Oh, is it?
Yeah. May 2027.
Wait, when is our mid-sem break?
Oh, okay. It is the May. No, it is during duty.
Yeah, everyone's still at
I think most people are still
most
at their
of us
own
will
time.
know
Good luck, Kevin.
apa
Every time one, he can run.
Yeah.
And he's in Gucci.
Realization which one you would use.
After PBL1 finish, then go straight for PBL2 kan. When's the due date for PBL2? Is it the same? Is it 3 weeks or so?
But then 3 weeks.
Yeah, right after midterm.
So right after our
Midterm.
midterm holiday, we straight away present.
Yeah,
On Thursday or Wednesday.
could be Wednesday. I'll have to check the date.
I honestly,
I don't remember personally. Hey,
okay. You have it. Structure. Vice.
consider you. So, you're gonna step up.
Double extend 51. Siapa tak nak?
It's not good.
Itu kan.
Okay, time.
I told you that people.
Oh,
Cepat.
yeah. I already give 5 minutes just now.
Fireball.
Ni boleh padam sudah?
Boleh.
Okay, so let's continue. slides. I think examples. Let's stop share, yeah. All right. Okay, so no more examples. Okay, that's it. Yeah. But we move on to the next method. Yeah. Now, what we have seen so far is when we are solving this type of ODE. Yeah. Now, this type of ODE is called homogeneous.
Yes.
Why is it homogeneous? Why is it called homogeneous?
Because 0 there.
Because because it is equal to 0. Okay. Now, if it is non-zero, if this is non-zero, then this is for example, homogeneous when G equals to 0, and it's called non-homogeneous when G is not 0. Okay, so that's what we have seen so far is homogeneous equation. Okay, homogeneous equation, we solve it using no, only one.
Oh, y equals to C1, y1 plus C2,
What's the method?
reduction.
No.
I only remember the W thing.
Russian. How did we solve a homogeneous equation?
Assume
first
y
one?
equals, assume that the solution is in the form of E.
E to the power of RT, right? So basically that one is using characteristic equation. Yeah. And we obtain characteristic equation obviously when the A, B, C are constants, right? Yes, you are right. After that, we learn few things because of when the roots of the characteristic equation becomes equal, then you have method of reduction of order. Okay, method of reduction of order is very powerful because can also be used when these coefficients are not constant. Okay, so method of reduction of order is when you are saying given y1 is a solution, then y2 equal to b, y1 is a solution as well. Then you hypothesize that, yeah, you hypothesize this, so therefore you masukkan type your homogeneous equation. Now we are going to look at what if it is non-homogeneous. Okay, so if it is non-homogeneous, then we will use method of undetermined coefficients, MUC. Okay, method of undetermined coefficients is that what we are saying is that we are going to use the solutions of the homogeneous part. Okay, we are going to use the solution of the homogeneous part in order for us to find solution when it is non-homogeneous, and that part is called the particular solution. Okay, So what it's saying, so next slide, slide 24 is a theorem that says if y1 and y2 are solutions of non-homogeneous equation, okay, this, then y1 minus y2 is a solution of the homogeneous equation. Okay, so then the y1, y2 are obtained from homogeneous equation. We can hence formulate that y1 minus y2, because y1 minus y2 is also a solution to the homogeneous equation, we can equate it to the homogeneous equation when we have the fundamental set of solutions. So when we rearrange this, okay, then it becomes the general solution. We are now in slide 25, which is the next theorem. It tells you the general solution for a non-homogeneous equation is in the form of y equal to C1y1 plus C2y2, which is the homogeneous equation, solution to the homogeneous equation, plus another thing. This is actually called the particular solution, or sometimes specific solution to the non-homogeneous equation. Right? Okay, so what is that? MUC. So we are going to, the aim now is to find this big Y. Yeah? How to find the big Y? Okay, so the method of undetermined coefficients, MUC, okay, is such that we are going to find the big Y by using or assuming that the solutions y1 and y2 obtained from homogeneous case can be used. Yeah. So for this case, MUC is only, I think, better to be used when the coefficients of y double prime, y prime, and y, they are constant. But the driving force G here, it can be any function of the independent variable. Okay? So it can be polynomial, exponential, or trig functions. All right? Okay. So let's work or learn this new method, the MUC, through example. Okay, so let's consider, now I'm looking at example 1 on slide 27. Consider the non-homogeneous equation. So you can look at that. You have y double prime minus 3y prime minus 4y. These are constant coefficients, yeah? You notice the ODE is constant coefficient. And the non-homogeneous part is an exponential function. All right? So by looking at this, okay, and knowing, because this is constant coefficient, hence you can solve it. Kalau dia what do you call that? Homogeneous. If it is homogeneous, then you can solve it using characteristic equation, right? So consider homogeneous part of the ODE. So we have y double prime minus 3y prime minus 4y equals to 0. So you can do as usual, as you RT, yeah, and so on and so on. Yeah, so you can obtain the homogeneous part. Okay, so homogeneous part is okay. Yeah, but you know that it is in this form, e to the power of RT. And you notice also that the driving force or the non-homogeneous part of the ODE is also exponential. Hence, okay, so okay, this one you need to like complete it lah to get the homogeneous solution. Yeah. So because what we are trying to do now is to find the particular solution. So the particular solution big Y, we say that assume big Y where big Y is equals to it is of this form. Yeah. So we have some constant e to the power of 2d. Yeah, because we are looking at the non-homogeneous part here. So therefore we assume that the particular solution has this form. Okay. Then because it is a particular solution, hence it is also a solution to the differential equation, the non-homogeneous equation. So we find substituting sub is y prime equal 2a e to e, y double prime equal 4a e to e into the ODE. So we substitute into the ODE. We have 4a e to t minus 2a e to t minus 4a e to t equal our non-homogeneous 3e to t. Right? Then we can, do some algebra. This one is 0, so it's minus 6, yeah? Okay, so straight away you can find what is your A, right? Minus 1 over
2.
Okay, hence particular solution is big Y equals to minus half E to T. Okay, the general solution to the ODE is now the general solution. So that's why you need to do this part first, because from here you will get the general solution for the homogeneous part, right? Y1, C1, Y2. So then whatever you get here, you need to put it here, plus the particular solution. So for this case is minus half E. Paham? Okay?
Yeah.
So that is the method, yeah? The method is to find the big Y first, the particular solution. Alright? Now, what if, now I'm moving towards example 2, slide 28. What if the non-homogeneous part is 2 sine t. Just now it was exponential function. Now it's sine. So obviously, because we say that, okay, because it's sine, hence I would choose my big Y to be sine t, yeah? So we have sine t, so A sine t. So then Y prime is A cos t, and Y double prime is minus, right? Minus A sine t. Now when we substitute this into the ODE, we have minus A sine t minus 3 A cos t minus 4 A sine t equal 2 sine t. Okay, so then we have minus 5A sine t minus 2 sine t equal 3A cos t. Okay, aku macam boleh saja. Betul lah. Okay, so then this one ini yang tak dapat. So we have A plus 2 sine t, and this is equal to 3A cos t. So you have A appearing in the coefficient of sine t, and A is also appearing in cos t. Hence, you are not able to solve for A. Okay, it's impossible to find A for this case. Yeah. Yeah. It's impossible. Yeah. So therefore, this is a wrong. This is not correct. Yeah. So this is not correct. We cannot use simply like this. So remember, when you see that the non-homogeneous part is a trig function like this, sine t. So instead of simply following, putting it as A sine t, we need to put it with the cos. So instead of A sine t, then we have A sine t plus B cos t. Boleh? Okay? So then your Y prime becomes minus B sine t, and Y double prime
minus B cos t.
minus A sine t minus B
Cos t.
t. Now we substitute. Kali lagi. Substitute it in. We have minus A sine t minus B cos t minus 3 A cos t minus right? So minus, so it's plus 3 B cos. Okay. Sine. Sorry. Sine. E. That's my Y prime. Minus 4 A sine t minus 4B cos t. All that is equals to sine Apa tadi?
2 sin t.
2 sin t. Okay, so now we collect terms. So we have minus a
plus 3
plus 3b minus 4a, that is sin t, then plus
minus b
minus b minus 3a minus 4b, that is cos t, and all that is equals to 2 sin t. Okay, so equate. Equating, so we have for sin t, we have minus a plus 3b plus minus 4a is equals to 2. So this is minus 5a plus 3b equal to. And then for cos t, we have minus 5b minus 3a equals 0. So a equals to
negative
5 over 3. Negative.
negative 5 over 17.
17 then.
Huh?
It's
Negative 5 over 17.
What's 17?
7.
From the slide, I mean, like
There are 2.
What happened? Why did I do something wrong?
Obviously,
Where? It's not obvious. If it is obvious, I can see it.
obviously no.
Seriously,
mana datang 7.
datang itu 17. Wow.
You should find the K.
Equals 0, right? From here.
But it's 2 equals.
This is equals to 0, right?
Yeah. So you
Betul lah. Haiya. Bodoh. I'm so wow. So this is B. I'm so sorry.
Yeah.
Hi.
I mean.
Sorry. Okay. Then, ya. Belum siap.
Itulah dia.
Hai, belum siap le.
We want to
Okay, so 1 into 1. Then we have minus 5 b over 3 plus 3 equal to, okay. So 25 over 3 plus 3b equal to 2. So this one becomes what? Mana itu? 3 minus 25b plus 9. 9 minus 25? 17, right? 6. 6 over 17?
3 over 7. Oh, negative 5 times negative 5 should be positive.
Okay. Then
25 plus 9. 4. 6 over 34 is 3 over 17.
Yes.
betul? Okay, terima kasih.
Yep.
Alright. So then minus over 17. Because of the 3 here, right?
Yeah.
Okay. Then it's the same as the slide, yeah? So the slide says y, the big Y is equals to minus 5 over 17 sine t plus 3 over 17 cos t. Okay, so remember, yeah, if your non-homogeneous part is of sine of cos function, then you try out both of them. Okay, a sum of sine and cos. All right. Boleh?
Boleh.
Okay. Next example. Is a polynomial. The non-homogeneous part is polynomial 4t squared minus 1. Okay. Now this is another tricky one. Based on what we have seen in the sine and cos function, you notice that the non-homogeneous part is of quadratic equation. Okay. So hence, instead of simply have two terms, you will need to have the general quadratic function, yeah, to try out. Okay, so your big Y supposed to be 3 terms, yeah. So you have at squared plus bt plus c, and then you do the same thing. You substitute inside your non-homogeneous ODE, and you collect the terms and you equate. Okay, equating t squared, t, and the constant part of the quadratic term.
Yes.
And then you will obtain your constants a, b, and c. Okay? True enough that the a, the b, and the c, okay, they are all non-zero. Hence, your particular solution is having 3 terms there. Boleh?
Boleh.
If the non-homogeneous part is cubic version,
Then the full cubic.
okay.
Yeah, it is quite long.
It is quite good.
Now, tengok ini. Ini product of 2 types of function. Okay, it's a product of exponential term together with trig function. Yeah, so therefore you will need to seek the particular solution such that you will have both cos and sine together with the exponential term. Okay, so the exponential term e to the power of t multiply with cos, and then e to the power of plus e to the power of t multiply with sine, and then you do the whole thing. Do the same thing, yeah, substitute and then collect terms and equate. Okay, so this is very important terms to use, collect and equate. In order for you to find these constants that you are putting into your particular solution. All right.
All right.
Now next, what if it is a sum? What if it is a sum? The non-homogeneous part is a sum of 2 functions, g1 and g2. So what it is saying here is that you can actually separate it. You can have the first non-homogeneous, where the non-homogeneous part is g1 and the second one is g2, and then y1. Okay, so y1 would be for this first one, y2 will be the second one, and hence the summation of this y1 and y2 would also be a solution. Okay, So it's the same thing, yeah. So which means that you will need to do one by one for some form of your G. Okay. For example, like this. Okay. You notice now I'm on slide 33, yeah. Slide 33, you have three terms which are being summed. You have exponential term, the first one, sine, and then cos. So which means you can do a separate one. So you do first for the exponential, then the sine, and then the cos.
Wait, so we do all three of them.
Yeah, you do all three of them. You find y1, y2, y3, and then you sum them.
Oh my God.
Okay, so you sum them. So this is for the first one. This is y1. This is for y2. This is for y3. So the sum of them is the particular solution. Ya, sangat panjang.
Keluar exam tak?
Tak tahulah, tengok.
Hey.
Alright.
Just let that. Just that. Only one question saja.
We'll see how. Okay. What is this? Okay. Now look at this example 6. Slide 34. Of course, when we see this, the non-homogeneous part is cos. So, following the method, we say that the particular solution have sine as cos. So, when we do, in the end, when you substitute, you get something like this. You lost the A and B. Okay, the A and B are lost. Okay. So that means there's no particular solution exists which is in this form. Why is that?
I don't know, man.
Why is that? The reason being because of the homogeneous solution. Yeah. Remember. Okay. Now I'm on slide 35.
35.
If you are looking at the homogeneous part, okay, the homogeneous part. You look at this, the characteristic equation will give you the root to be imaginary, complex, right? Complex. Yeah. So therefore, your general solution will be sine and cos. Yeah. So that is the reason, because the homogeneous solution is already in cos and sine. That's the reason why you cannot have your particular solution to have of this form as well. Okay. Okay. So instead, we will need to include a t there. We multiply it with the independent variable. Then do, and in the end, you obtain it to be simply 3/4t sine. Yeah. Okay. So it's because of that.
So it is when the hormone.
That's why you need to also check your homogeneous solution. Yeah.
Whether it is complex.
Yeah.
It is complex roots or.
No. Whether it is also the same as your non-homogeneous part. Okay. So if it is the same, because there is cos and sine appearing in your homogeneous solution, and in your non-homogeneous part is also cos or sine. It's cos, yeah. So that's the reason why. Okay. Then you will have to multiply it with t. Okay. All right. Done. Finish MUC. So next Wednesday. Next Wednesday. Yeah. Next Wednesday, I will finish off this learning unit where we learn another method, much more heavier than MUC. So MUC, look at non-homogeneous equation. Method of variation of parameters also look at non-homogeneous equation. Okay?
Okay.
All right. Thank you so much.
So tomorrow tak ada kelas.
Tak ada.
And then next week.
Next
I
week,
can look.
masih hybrid or
Next week masih hybrid lah. Mereka masih,
Oh.
ya, masih lagi. So next Wednesday we'll still meet here. Okay, you cannot guarantee, that's fine.
Guarantee you.
You guarantee Kevin will be here. Okay. All right.
okay, still got me. I'm still cooking. Orang kucing.
So do you prefer it 9 or 9:30 or 10?
Actually prefer earlier.
Ayaw, more cool tayo.
Cause I'm here at 7.
Oh,
So, I think that is fine. 8:30, 8:30.
No, like keep it at 9.
Like,
Oh, I think
I don't want to stop. Yeah.
Yeah, jam.
I'm here
Okay.
at 7 anyways.
All right, thank you so much.
Oh, you.
Salam Idul Fitri to all who are celebrating ya.
Yes.
Selamat Hari Raya, maaf zahir dan batin. See you next week online again. And those who are very helpful and want to accompany me, welcome here.
Yeah.
All right.
Kevin only.
Okay. So Wednesday next week at 9 a.m. Thank you. Bye-bye.
PBL tu pun keluar hari ini juga.